right, we are going to start today the Unit 7 review test. In your activity book, it's on page 287. All right, so let's look at number 1, and we're going to compare these fractions. So we've got a mix here. I've got fractions with the same denominators, fractions with the same numerators, and some little bit of everything. So let's good review. So when we have two fractions with the same denominator, it's super easy because we can just compare the numerators. So this is saying we've got 1/5 versus 3/5. They're the same size piece, so I know that 3 of them is going to be greater than 1 of them, right? Now remember our trick, we can multiply across or diagonally to check. So we can multiply 5 times 1 is 5, and 3 times 5 is 15, and that confirms 15 is greater than 5, and 3/5 is greater than 1/5. So let's do these with the same denominators first. This one has the same denominator, 5/8 and 7/8. When the denominators are the same, we can just compare the numerators because we know we're dealing with the same size piece. So 7 of them is going to be more than 5 of them. Now, when the numerators are the same, we can think of the denominators. The larger the fraction, the larger the denominator, the smaller the piece. Okay, so 12ths is going to be less than 10ths. Or we can multiply diagonally. 10 times 9 is 90, and 9 times 12, I know that's going to be more because 9 times 10 is 90 plus 18 more, so that would be 108, which is more. Then I've got 2 and 2. My numerators are the same. The denominators are different. So the bigger the denominator, the smaller the piece. And I can multiply across diagonally to check. 8 times 2 is 16. And 3 times 2 is 6. 16 is greater than 6. How'd you do? Okay, choose the numbers from the tiles to make an equivalent fraction with the least possible denominator. So don't get confused by these tiles. We're going to work with those numbers in a moment, but we want to have the least possible denominator. The denominator is the number on the bottom. I know I want to get a small number. So if I want to make this smaller, and I look at my choices, 2, 3, 4, and 6, I feel like if I'm going to find an equivalent fraction, I'm not going to multiply here. I'm going to divide, right? So I'm just going to practice over here and see what I can get to. So I'm going to take 8/12, and then whatever I do to the top, I have to do to the bottom. So I've got to find some factors, numbers that are both factors of 8 and 12. So I can think, what can I multiply together to get 8? I'm going to make a little T-chart over here. For 8, I can do 1 and 8, obviously, and 2 and 4, I can go in order. And then I can make another T-chart for 12. I've got 1 and 12, obviously. And, oh yeah, 2, 2, and 6. So I could divide both by 2. Let's see what I get. So 8/12 divided by 2 halves gives me 4/6. Okay, I could go with that one. But I'm thinking that I have something even greater that I could work with here. I noticed that 4 is a factor. So 3 times 4 would give me 12, and 2 times 4 is going to give me 8. So what if I take my 8/12 and I divide by 4/4? I'm going to get even smaller denominator. 8 divided by 4 is 2. 12 divided by 4 is 3. Now, I could have also divided 4/6 by 2 to get to the same place. 4 divided by 2 is 2, and 6 divided by 2 is 3. So I can move these tiles over. If I was on the computer, I would move 2/3. Got it? Farid measures the masses of 4 books in kilograms. He records the data in the table. Which 2 books have the same mass? So the mass is the weight. So we've got book 1, book 2, book 3, and book 4, and we're looking for the 2 that are the same. So here's 1 and 12/100, which I'm thinking like $1.12 if I wanted to pretend it was money. I've got 1 and 2/10. These are not the same. I've got 1 and 2 hundredths, which is not the same as 1 and 2 tenths or 1 and 12 hundredths. And I've got 1 and 2 tenths. 1 and 2 tenths, 1 and 20 hundredths. These two are the same because if I add a 0 here, I don't change the value. So books 2 and 4 are the same. Number 4, in a survey, 7/10 of the students said they watched the news last week. Complete this fraction equation. So I've got a denominator of 10 here, and I'm going to a denominator of 100. I see what we're doing. We're multiplying. 10 times 10 equals 100. Whatever I do to the bottom, I have to do to the top. Whoops. I'm not going to multiply by 7. I'm going to multiply by 10. 7 times 10 is 70. How you doing? Let's go on. Number 5. A trail is 7/12 miles long. Select the trail length that is shorter than 7/12. Mark all that apply. So there could be more than one. This is the trick. There could be more than one. So I'm going to compare each one of these. 3/8 and 7/12. 2/3 and 7/12. 3/4 and 7/12. And 1/2 and 7/12. And I want to look for the ones that are shorter or less than. So I've got different numerators and different denominators. So I'm going to rely on my trick of multiplying. Diagonally, 7 times 8 is 56. 3 times 12 is 36. So 7/12 is greater. So that means 3/8 would be less. So this one works. I'm going to multiply diagonally. 7 times 3 is 21. 2 times 12 is 24. 24 is greater. That means this would be greater than 7/12, so this one does not work. I'm going to multiply diagonally. 7 times 4 is 28. 3 times 12 is 36, which is greater. So 3/4 is greater than 7/12, so this one would not be shorter. 1/2 and 7/12. I'm going to multiply across. 7 times 2 is 14. 1 times 2 is 12. 7/12 would be greater, so 1/2 would be less.